In this video, we're going to look at a normalization exercise on parking tickets, and we're going to go to the third normal form. So we imagine this table. I'm not showing you any sample data this time, but I'm telling you the fields and what is, at least for now, chosen as a primary key. So imagine a parking ticket, and it tells you the date and time and badge number of the officer, as well as the officer's first name and last name, the license of the car, the make of the car, the color of the car, the street on which the ticket was issued, the owner of the car's first name and last name, and then the amount for the ticket. And we're assuming that the primary key is already established as the date, time, badge number. So the primary key should be something that uniquely picks out all the possible rows on such a table. And so we imagine that each officer, that there are unique badge numbers, and that at a given day and time, the officer can only be issuing one ticket. So that should be a reasonable primary key for such a table. And then the first question we're going to address is, are there candidate keys? Are there other possibilities that we can think of? And so what are the other sort of possibilities here? Uh, we have to imagine the scenario, like what are the rules of such a thing? And so let's say that a car can only receive like one ticket in a day. So if a car has been ticketed, uh, you know, on Thursday, that it can't be ticketed again that same day, that we have to let 24 hours go by or something. So then we could say, then a possibility is say date and car license number. Because the car license number will identify the car, and then the on that date only that car could only have received one ticket, so that would pick out a possibility. And then let's say a person might have more than one car, and even that person's vehicle or more than one vehicle might be getting different tickets, but it's at least extremely unlikely that they would be at the same time. So we could say a date, time, and then some owner ID, or we could use the first name and the last name. Let me just make up an owner ID. And all we're saying here is like, okay, so these are possible candidate keys, things that would identify unique rows. So we're going to use date, time, badge number, but we could use these other things. Okay. Now, any of these combinations, any of the actual primary key or these candidate keys, sort of if we have all of those fields, then those fields will determine all other possible things. So what we mean by functional dependence is, does one thing determines another? And uh, so that combination of things determines all other fields, because that's what we mean by a primary key. And by determine, we mean it's unique and we can look it up. So we're looking for things that are, other things, or other parts of things, and so well, we have uh, one thing we can pick out is that the officer's badge number will identify the officer's first name and last name. So we can go to, if we know the badge number, we're going to be able to look up the officer information, get the first name and the last name. If we know the car license number, we're going to assume here that everything's above board and not that they've, taken the license off one car and put it on another car or anything like that. But so then we will say that the car license number is going to determine the car make and the car color. So there we go. And then what did I give? I gave some kind of so the street the street is not deter you sort of need the full parking ticket to determine the street because it's not necessarily where the owner was lives or where the owner works. It could be any place, any odd place. And so we're going to need sort of everything all about the ticket to determine the street. So there's going to be, we just need everything then. And so it's not going to be terribly interested. We're interested in sort of other things other than the full primary key. So it's going to take either the full primary key or the full candidate key to determine the street. So we're not interested in. I made up an owner ID that wasn't there before, but now I have it. And so that could be this owner first name. I don't know what that might be. It just might be we assign, make up an ID for somebody who's in the system. And then the amount's going to be rather like the street, I think, and that um, it's going to sort of depend on um, the circumstances. I mean, I don't know what they base the amount on. Sort of like the violation. Were they in front of a fire plug, or did they just sort of were parked in a 2 hour spot for 3 hours? That such things might have different amounts. Fact is, I just don't really know. So we're going to imagine that that depends sort of on everything. Um, so what do we have? We had the badge number determining something, the car license number determining something, and then this owner ID that I just sort of made up whole cloth, determining something. Okay. So now we're looking for partial dependencies on the primary key. And there are games one plays uh, in normalization of do you are you talking just about your primary key of choice, or are you interested in your candidate keys? And so that is, um, are we talking about partials are going to give us what we call the second normal form. And then we have this question, are we talking about the uh, generalized second normal form, which we will consider not just the primary key we choose, but all the candidate keys, or are we just going to consider the original primary key? So let's go with just the original primary key. And so we're looking here which of these pendences are um, on a primary key. Well, what was our key? It was date, time, and badge number. So the badge number determining the officer, that's clearly, with our choice, a partial. Now the car and the car license number, no, that's not part. But if we were doing generalized second, car license number would be partial if based on this candidate key, and owner ID would be a partial dependent on this candidate key. But let's just go with the sort of original definition, just not generalized primary key or generalized second normal form, just second normal form based on the primary key we chose. So this is a partial. So now we're looking for transitives, and that means that something, some field or set of fields determines a field B, and then B in turn determines some field or field C. So these ones up here that were uh, not we're not going to turn into partials in a generalized version, they're going to be at least transitive. And so we can take our primary key, date time badge number, and that combination determines everything. But that's going to determine the car license number, which in turn, not VAR, but car license number. Um, and that is going to determine the car make and the car color. Pardon me. And similarly up here, the date time badge number will determine this owner ID that I just made up, and which will determine the owner first name, owner last name. Okay. And then we want to uh, use this to uh, break the table up. So then second normal form says we should uh, pull out the officer first name and last name into a separate table. So let's copy sort of our original table and then pull things out of it. So we have our original table, and then we're going to start pulling things out. So there's our table, but what are we going to pull out? We're going to pull out sort of um, an officer table, and that's going to be the badge number, and that's going to determine the officer first name and last name. So we're going to take those out here and put them here, and there we go. All right. So, and that will be officer. So we pulled out our partial on the badge number. That's what second normal form told us. Third normal form tells us to pull out the transitives. So this is telling us that car license number is picking out the car make and the car license. So we're going to pull out make a car table, and that is pulling this out. Control V, okay, and car license, car make, car color, and this is that. Okay, so we pulled out the car info. We're going to pull out, and that pulled out these. And then we're going to pull out the owner, and that will be that owner ID that I made up, and then pull out. So I'm going to put an owner ID in here, and then pull out the first name and the last name separately. And so that is another table. And now we might, so we have here the car license and the owner as a relationship within the parking ticket. And so we're thinking about our relationships. The parking ticket is issued by an officer. Um, so a parking ticket is issued by one officer. So the parking ticket will have the badge number as a form, serving one of its primary keys in a composite key. We might introduce a ticket ID when we're all done, but not just yet. But the badge number is serving as a foreign key connecting the parking ticket to the officer. And the car license number is serving as a foreign key relating it to the car. Um, we right now have the owner information still in the ticket, but we might pull that out to have a sort of car owner table. Because if somebody uh, gets like ticket after ticket after ticket, and we're trying to reduce our redundancy, then uh, that that life that person owns that car can this there may be many tickets, but there's only one relationship between this car and the owner. So we might pull that out to be just a little bit less redundancy. That is our goal. So let's do that sort of bridge table of a car license number to identify the car and owner to identify the owner. And then I can pull owner out of here. I can't pull car license out of there. The person might own more than one car. So we're going to imagine that the car, or maybe now that I'm thinking of it, this might be better. If the car has one owner, then this might be so. Let's assume the car, we have to, if this is car owner down here as a bridge table relating car to owner suggests a many to many relationship. And then we could say that a car is owned by many owner. A car has many owners, and an owner may own many cars. Certainly, the second part is true. A person can own more than one car. Do we associate the owner of a car with a single person? If we do, then we can put owner here. So let's do that and take this out and then but say here um, that we would need this would need if car if the car owner relationship is many to many. So if it's and then this part here sort of is the accompanying thing. So if the car owner relationship is one to many, if a car is owned by one owner, then I can put the owner ID here in the car table. If the car owner relationship is many to many, then I'm going to need a bridge table. I'm going to, I think, assume that there's one person owning a car, and then I'll need four tables: the parking ticket table itself, the officer table, pulling out the officer information, the car, pulling out the car information, and the owner pulling out the owner information. But the car owner relationship is in car if it is one to many. But if the car to owner relationship is many to many, then I'm going to need a separate car owner table. So we always ask these questions along the way and make our assumptions, try to make our assumptions explicit. So this answer depends on the answer to that question. Am I going to break it into four tables or five? That depends on the answer to that question. So you should sort of state your assumptions and then and always look it up or talk to other people. So I'm the sole owner of my car, but there may be, it might be possible. We have to look up and find out for sure. Is it possible that a car has multiple owners? And that's officially not two people share it, but like, is it officially in the ticket system owned by just one owner, or can it have multiple owners? And I do not know the answer to that question. So I have two possible answers depending on the answer to that owner-car relationship multiplicity. Okay, that's enough for this one. Thanks for your attention.